So, the operating system itself has some kind of logic to it, like both the Mac and Windows, and for that matter, Linux, will have a user profile where you put your stuff and various standard ways of handling things, but applications don't necessarily obey that as much as they should. Although they do, all modern applications do at least put user-specific data in the user profile and generic data in a relatively controlled external location, but the formats of the files and how they store them and what they store is just arbitrary decisions made by the developer of that application. So in principle, every application could be a research project you have to figure out, but there are a few that are very common and very important. And here they are. These are your internet browsers, email clients, office suites, and chat programs are the ones that everybody uses, where there's only a few brands that matter, and there's almost always data you need to see in there. In almost every investigation, you want to know what websites people are going to, what they've been downloading, who they've been sending email to, and things like that. So in principle, the application data could be stored in any format at all. Text is the nicest to search and the nicest for long-term sustainability. This is why Microsoft Office finally moved away from proprietary binary formats to just plain text XML, because if you survive in this business for a couple of decades, you wish you hadn't made stupid binary formats that nobody understands, that can't be easily extended, and you just use something plain like XML, where you can easily add something new to it, and you can easily make your stuff backward compatible with earlier versions. And that's what Microsoft finally figured out. But anyway, so you want to find where the application data is stored. In Windows, you install things in C program files by default. That's where most apps go, although not all. And if you have a 64-bit system, you put the 32-bit things in C program files x86, which doesn't exist on a 32-bit system. And that is specific to Windows. I know on Linux, you cannot run 32-bit OS on a 64-bit. You cannot run 32-bit apps on a 64-bit OS, not without installing special libraries, and I think the same thing is true of the Mac, although I'm not sure. Anyway, and your application data can go in C program data for generic things, and in the profile app data folder, which is hidden, and that's also a system reserved file for the personalizations that apply to only that one user. So that if they log out and somebody else logs in, they'll be there, and that's where you'll find things like your name and your title and your phone number to automatically fill in on Microsoft Office documents. So when you install it, it has a registry list of how to uninstall it. And this is what the default uninstaller will do. This is one of Microsoft's more buggy products. It is famous for not really cleaning things off, which is largely why Windows systems get slower and crash as they get older, because every time you install something and uninstall it, it doesn't really uninstall at all. It leaves chunks behind that get in the way. Anyway, there's in the software in Microsoft current version uninstall registry key is information about how to uninstall things. And again, on 64-bit Windows, you have a special thing in this WOW 6432 node, which has to do with the virtual machine-like process that's used to run 32-bit apps on a 64-bit OS, which is very convenient for Windows users, but it does involve special extra features throughout the operating system to support that strange activity. All right. So the registry configuration is in software, and again on 64-bit systems. For 32-bit software, it'll be in a special place called the WOW 6432 node, because the 32-bit app does not get to see the real registry or the real file system. It sees lies that are constructed by a redirector in the operating system that looks in here to tell it what lies to tell 32-bit OSs, so they think they're running on 32-bit Windows when they aren't. The end result is spectacularly effective, and you can use 32-bit software easily, but it's doing an awful lot of sleight of hand behind the scenes to make that work. Anyway, OS 10, all the apps go in Applications, and the user data is in your Library Application Support folder, very much like Microsoft's App Data. On Linux, in principle, it could be anywhere, and each app has their own tradition and stores it all over the place. So there's two ways to do it. One is if you have a package manager in your Linux distribution, it will have information there about where pre-compiled packages go, like apt-get on Ubuntu, or you can inspect the file system with things like grep to find things. There is, however, a standard for Linux which nobody is forced to comply with, but this is where you're supposed to put things. This is why these certain folders you'll see on every system, ets and user local ets, these are directories where you should put system-wide app configuration. User application data is supposed to be in a home username. Executables are supposed to be in bin, sbin, user sbin, and so on. All these things ending in bin for binary executables. And add-on software might go in opt. But people can break these rules, and there's not much enforcement. So if you're using Red Hat or the variants in its family like CentOS and Fedora, and also OpenSUSE, which is not Red Hat, but it also uses the same package manager, it uses the RPM. And like this is the standard recursive definition that people love to do just sort of to irritate people who don't know math, is RPM stands for RPM Package Manager. The R stands for nothing. It's a little joke intended to confuse you. And this is what happens if you learn symbolic logic and you want to sneer at people that don't know it. Anyway, so here's the RPM query, which will query and find all the installed software and the date it was installed. So the package manager does have that information, and in Ubuntu, you've got a graphics package manager, I think it's called Nautilus, and you can just list all your things there. Just like in Windows, you can go to add or remove programs and see all the installed things just right there in a graphic list. The Yellow Dog updater is used with RPM on some of these distributions, and you use yum to put things on, the way you use apt in Ubuntu. And it's got a log that shows all the packages that were installed, updated, and erased. In Debian, you've got essentially the same thing with just different names. Ubuntu and Knoppix in the Debian family. You've got dpackage is the package manager. Packages come as files ending in deb. And then you can do a dpackage here to get a list of all the installed packages. And you can use the advanced package tool apt to get things, and it has logs. It's just exactly analogous to yum. There's, not in your book, but it's sort of amusing. I learned when I did Solaris. There's a very similar system in Solaris, except it totally doesn't work. The manual tells you can run the graphical environment, and when it crashes, you go back to this command line tool, because they never actually got the graphical environment working, and even their official documentation admits that. Anyway, but Solaris seems to be going the way of the dodo bird. All right. So in general, you may have to research to figure out where an application stores things. This is tricky. If you don't understand research too well, most people don't, it is very easy to fool yourself. You do something, you think you understand what something is, and it turns out you're totally wrong. So it is, in a high-stakes investigation like a criminal trial where someone is going to go to jail, it is not a good idea to try to do research yourself if you don't have experience doing it. It would be better to actually hire a consultant that really is an expert on that piece of software. But for lower stakes things, you might just figure it out yourself by trying things. If you're going to do this, there are resources out there you can look up what other people have found out. There's a bunch of forensic blogs and bulletin boards where people spend their time figuring out every little app and posting what they figured out about it. But none of that stuff is necessarily accurate. None of it is reliable if you change versions and operating systems and stuff, so you have to watch it. And this is why the forensic sounds scientific, but in fact, when it's all over, it seems to be just about as risky as things having to do with fingerprints and blood spatters and stuff. You're the expert because it is your judgment, given the evidence, whether something happened or not, and it's not like you mathematically prove it to be true. You make a reasonable judgment based on your experience and various clues. Anyway, Encase and FTK will automatically analyze a lot of applications, just make it easy for you to see, but they are just doing their attempt to reverse engineer things without documentation, just like everybody else, and so sometimes their results are wrong too. So anything important you have to verify with two tools, because every tool is just somebody's best effort to figure out what was going on, followed by their best effort to code some automatic way to do it, and there can be mistakes. So if you're going to research something, first you configure an environment, which should of course be as close to the environment of the purpose you're investigating as possible. Put in the application. Then you install some kind of instrumentation that will analyze how the system performs. This is the same thing you do for malware analysis, and it makes a little more sense when it's not malware to imagine that your instruments will run well. Anyway, then you install the thing, execute it, look at your instrumentation data, and then reperform testing until you decide what artifacts are created and how they compare to the artifacts you observed. The environment should be a virtual machine as close to the actual suspect's environment as you can make it, of course. It would be best to have the exact same version of everything and patches and such. And you have to run some kind of tool. Now in Windows, the main one you use is Process Monitor. Process Monitor is like Wireshark. It will run and create a ton of events, thousands of them, and hundreds of thousands of events per second, and eventually fill up all the RAM and crash. So you run it for a brief period of time while you're doing something and then stop it and analyze it. And there's similar tools for OS X and Linux. This is what we do in malware analysis. The class is coming around next semester. This is the easiest and most effective way to analyze malware. It is also sloppy and dangerous. is you take a machine and you deliberately infect it with the malware. And then you have running tools on the machine, on the compromised operating system, supposedly recording what's happening. Smart malware will not be decodable this way because it will kill your analysis tools, but dumb malware will fall for it. However, you're also creating an infected machine, which may then attack machines around it and try to infect them, and it may phone home and it may participate in attacks. So it's a pretty sleazy, dangerous thing to do, but it's the most popular way to do it because in most cases it's the fastest and easiest way to find out what the malware is doing. Just run it and see what network traffic it produces, what files it makes, and so on. And you're doing the same thing here, although the stuff you're running is not malware, so it makes more sense to believe that your operating system is going to run all right and your results are probably reliable. So here's an example. This guy finds putty in the prefetch folder. Putty's just a normal SSH client. It's not malicious at all. But he has a question like, the putty has been uninstalled. This sort of suggests that the perp was using putty to do something they wanted to hide. So they uninstalled it. But when you uninstall things, they don't go out of the prefetch folder. One of the things perps typically don't know, and you remember seen throughout the class, the thing that forensic investigators love best is something that remains even after you delete the thing that caused it. So we know what you did even though you tried to hide that. So the question is, can you find out what they were doing with putty, even though they've uninstalled it? And so, to make the analysis, you set up a Windows machine with process monitor, then you install putty, then you run putty and log into something, then you disconnect, then you'll stop process monitor, and you try to see, did putty record what I connected to somewhere on the system? Process monitor watches everything, and I think all it's actually doing is viewing the Windows event logs, but it does show everything, and like I say, 463 events over 16 seconds, but none of them are file activity. It did not write any files on the disk at all. So you're probably not going to find any file on disk that records what server I connected to. But he found a registry set. There's a registry set here which has software Simon Tatum, putty, SSH host keys, and here's the IP address you connected to. So apparently it writes a registry key every time you connect, and so you might be able to find evidence in the registry of what they've been doing with putty. If this actually stores enough of these things to record interesting information and they don't get removed when you uninstall putty. So that's a start. Now, you want to watch it. You might assume that Simon Tatum here is the person that connected to putty, but it's not. It's the author that wrote putty. So I say, it's very dangerous to jump to conclusions. You have to be careful about how you analyze the results of research. But here's some issues. You may show servers it connected to, but there won't be timestamps because there are no timestamps on values in the registry. There's only timestamps on keys. So you'll know like the last time it was used, or maybe the first time it was used, but you won't know a time when each of those things happened. The Hive is also user specific, so you have to search each user's Hive to find all the evidence, but there's some information stored there about what people have been doing in putty. And you just have to be cautious about how much weight you give evidence that comes from your own research. Beginning researchers almost always jump to conclusions from inadequate evidence, and they fail to realize how dumb you can be. It can look obvious to you, but you have to really try it many different ways to prove it's really true. Yeah?
Are you recording?
Yes.
Okay.
You don't want to say your thing if I'm recording?
Yeah.
Well, I'll stop for the break. In 20 minutes, you can say it then if you have a secret. That's fine.
No. I thought you weren't recording.
No. I'm attempting to record. I think it's happening.
Awesome.
Yeah, because especially today, I think there might be some people absent and want to look at the recording. Anyway, all right. So, let's see if this thing is going to work or what. It's working. All right. So which one of these do you find only on 64-bit systems? All right, I'll quit at 30. All right, and that's B. Hopefully, not a surprise. There we are. Okay, good. Everybody knows that's there for 32-bit code running on a 64-bit OS. All right. This, by the way, is still used by 64-bit things. This 32 here was not changed for some reason. Anyway, there's a lot of that in Microsoft. Stuff left over from the past that is no longer accurate, but that's the way it is. It's what you get for surviving long enough to have many versions of your system. All right, so where is user application data in Linux? Quit at 30. All right, and it goes in home. Home username is where it should go. Things specific to that user. Good, a popular answer. All right. All right, where's the system-wide configuration data? All right. I'll quit at 30. All right, you find that stuff in Etch, things like Etch Apache and so on. All right. These are where executable files are in the binary files. That's not configuration data. All right. And what utility manages packages on Fedora? Quit at 30. All right, and that's Yum. Yum is their equivalent of apt. All right. All right, so next thing is web browsers. Web browsers are becoming a monoculture again. 10 years ago, it was a monoculture. Like Internet Explorer was like 99% of it, and everything else was of no importance. Now it's pretty much Chrome has totally taken it. Firefox is number 2, and IE is down in the chains like Safari. IE would not even be worth worrying about, except for corporations. The large number of people that use it are people inside corporations, because if you're a large corporation, you have to use Windows servers and Active Directory to manage security and maintain patches and such for giant enterprise. And if you're using Microsoft domain controllers, you pretty much want to use Microsoft's version of everything to make it work best. So you use their browser, their chat client, and everything, and that's the main use of IE. Anyway, so IE is more important than you would imagine just from this number. But Chrome is definitely the elephant in the room these days. And you can see it here. Here's a graph showing it. Blue is IE. Long ago, like in 2008, IE was pretty popular, but it's just been falling like a stone. And at the same time, Chrome, which is the green line, has been growing like crazy. And all the rest are sort of competing for 4th and 5th and 10th place. All right. So the main artifacts you find in your browser are history, cache, and cookies. Those are obviously very handy. They'll show you where people have been going, what they've been doing, and often whole pieces of pages they've been looking at. There are commercial tools out there, like Magnet Forensic, Internet Evidence Finder. I've used in this class in the past. I don't have a license right now. I may be able to get one before the end of the class. By the way, there are 2 extra credit projects that involve taking evidence from an iPad, and we just got another iPad for the lab to use. So we now have an iPad in the lab where you can take out, you can do things on it, get the evidence off the iPad, then analyze the evidence. So that's the thing to know. All right, and I'll see if I can get another key for Internet Evidence Finder, but I think I don't have a current one. They only give you like a 15-day free trial, so I have to keep begging them every semester to give me another 15-day free trial. Anyway, the thing is, a lot of this stuff, anything related to iPads is super expensive, and Evidence Finder is no exception. Nersoft has a bunch of free things that will let you see browsing histories and other things for various browsers. They just have a lot of tools, like several tools for each browser. This is what tends to happen. If you have a lot of money, you buy a monster like Encase or FTK, and it just does everything. And if you don't have money, then you get a bunch of little tools to do one little thing. You end up running a whole lot of little tools to get this little bit of evidence and that little bit of evidence. Redline can supposedly suck data out of a browser too. Like I say, Redline, you've had your project with Redline. Redline's not as nice as I hoped it would be. So I'm not so sure. But anyway, at least it's free. All right, so Internet Explorer, the standard of corporations, you'll find autocomplete. Autocomplete is where it remembers credit card numbers, passwords, your address to fill in forms, all sorts of good stuff is in there. And a lot of people do store things in Internet Explorer. And every version of Internet Explorer, Microsoft made it more secure, more encrypted, but it always gets hacked into in a hurry. Anyway, so this IntelliForms stuff is where the autocomplete is. Down here is the typed URLs, which you've seen. This shows you the URLs that people typed into the bar to get to, not the things they went to with favorites by clicking on links. and then you got preferences down here for the browser. And you've got a cache. The cache contains fragments of pages that were stored just to make performance faster in case you go back to the same page later. So it's got random fragments of images and movies and HTML for pages, but sometimes you'll see pages more or less in their entirety that you can see. Then you got bookmarks, of course, that's handy, see what people like, and the cookies will tell you where people be going. Yeah.
Curious, I'm looking at cookies right now. What's the low section, by the way? I'm kind of curious.
Oh, this is a fundamental issue of Microsoft. There's local low and low, and I think it has more. What local low does is you can be in a browser and you can go to a page that tries to write a registry key. And remember, and like it does for 32-bit apps, the browser will lie to the web app. If it says, write this registry key, it will put it in a folder called low, for low privileges, and then it will tell the app at the other end, yes, I wrote that registry key. And when the app tries to read it, it will go to this folder and lie to it and tell it it's there, just sort of like a virtual machine. That's what they're for. It is so you can have old web apps that try to do things on your machine the way they did with Windows XP and Windows 2000, and they don't know you're running on Windows 7, and now you're a non-administrative user. And the app will still think you're the administrator, and they'll think they're making changes in the root of C in all sorts of dangerous places, and the app will run, but it will not actually change the root of the C. So what it is, the way the system we talked about a little while ago makes a 32-bit app think it's running on 32-bit Windows, and it's really running on 64-bit Windows because the operating system has a table of lies and carefully lies to it. This lets apps written for Windows XP that assume you've logged in as administrator run and think that is the situation when you're in fact in Windows 7 or 10 and you've logged in with a low privilege user. So that's what they're for. Anyway, and I think for practical purposes, you don't really care. Anything you find in either place is something they really did, but that's why they're there. And that's, that Microsoft is, I think, more advanced than anybody at making code written for a different version of the OS run on the new version as if it was fine, because they have a lot of features like this. Anyway, so IE has a history file. We talked about this. The older versions of IE sorted in these proprietary binary index.dat files that you had to get a special viewer for. In IE 10, Microsoft moved to something called the Extensible Storage Engine database format. And I'm not quite sure what Edge uses. Edge being the new thing that replaces IE entirely in Windows 10, I think Millennium Edition, or whatever it's called. Millennium Edition? Something like that. Millennium Updaters.
You mean the edition that came
The
out?
latest version of Windows 10 is, I think, Millennium Update or something.
Yeah.
And that's got Edge, I think. Anyway, so here's where the index.dat files are all over the place. You can get them, and then you have to use a special index.dat viewer to open them. And then you'll see the history, the browsing history stored in these places. Yeah?
Why would you want to look at the trash can?
You can open the trash can and just drag files out. And I think there's also a trash can viewer. Things that will, a forensic image that will open the trash can, but I don't know the name of the utility right now. I know Encase will do it. And FTK, of course. And so here's the ESE things under these web cache files. So that's the cache. That's what the file is actually stored in, and you have to use a viewer of some sort to open that and remove out the pieces. So here's Nursoft has a free cache viewer that will let you see what's in there, and it'll also let you see history, cookies, and autocomplete. Nursoft has free software that will do all these things, but you have to run a lot of different tools to pick out each thing. If you pay for a huge forensic suite, it will all just be there in the tree structured directory. Like if you've done the education, the FTK projects, all these things are just reassembled and put in a folder right for you. So it includes equivalents of all these tools in one big giant suite. So Chrome, probably the most popular. Chrome has a couple of features that are a lot different than Internet Explorer. Probably one of the most important ones is everybody's always running the latest version of Chrome. It has auto updates and it's quite vigorous about that. And Chrome changes very fast. The plan of Google was to update Chrome every 6 weeks, and they have more or less done that. So the latest version is like 65 or something, and it's constantly updating and constantly changing. Anyway, it stores these things in SQLite databases and JSON files with no file extension, and here's where it puts them. C user username app data local Google Chrome, and on Linux it puts them here, and on OS 10 it puts them there. All similar locations. And so the history is stored in URL and visits tables in the file history, which is a database. So you can do a query against that database, and here's the query that will find URLs and the title of the page from the URLs where some ID equals visits. This will give you information about a viewer's browsing history. And you can write other queries to run against the database to get it. Or you can just look at the whole database in SQLite Viewer. There is an archived history in addition. The original history only goes back a certain amount of time, 3 months, and for things older than that, it reduces the amount of data kept and keeps it longer. So there is history all the way back by default. Quite a way back anyway. There's also, this is even more fun, Chrome was the first browser that started using the address bar as a search field. You can just go to the address bar and type in flowers, and it will decide that's not a URL and send it to Google and search it and give you hits for flowers. So that, and then it will store it in the history index, because the next time you go there and start typing, the purpose of this is so it can autocomplete. I'm used to this all the time. Anything I go to all the time, like every night when I go home after class, I want to upload my files, so I type in Y, and it already knows I'm going to YouTube. It guesses. And when I want to put up these slides, I type in S and it goes to SlideShare. It remembers what you do a lot, and it very efficiently finds it. I don't even have favorites much, I just use this instead. But it has a database of everything you've been doing. And now the database includes not only the URLs you've gone to, but the terms you've been searching for. And you've probably seen, I've certainly seen the FBI reports and news articles, there's a lot of people that get arrested, and then they say, we found the week before you poisoned your wife, you were Googling how to find a poison, how much poison to take to kill people, you were Googling how to make a bomb, you were Googling how to break into a bank. This is the kind of stuff. They know the terms you were searching for. And this is the kind of evidence that gives you that. You can also get that evidence by getting it from a provider, but it's on your machine in Chrome. So that's pretty cool. You now have not only what page they went to, but what terms they were looking for that led them to that page. Yeah?
Wouldn't incognito mode not log in?
That's a very interesting question. And I always wondered how effective these things are, and it'd be fun to know. If I go to incognito mode and I type SlideShare, it still pops up. So it's still using it, but I suppose if I go somewhere new, it won't add it to the index, but I also would be willing to bet that it's not very accurate. I mean, this is not really intended to hide your evidence from a criminal investigation. This is just intended to make it not glaringly obvious to, like, your wife that might want to see what you've been doing. So, as far as I know. So I wonder, it would be a very good project to get the evidence with a professional tool, then go to incognito mode and do stuff and see what evidence is still there, because I bet it doesn't stop at all. But it certainly removes some of it. Like, I know it doesn't go in your history, and it doesn't retain the cookies. But yeah, it's a good question. Incognito mode certainly does something to prevent some of this evidence being stored, but I bet it doesn't block it all. Yeah?
Well, clear history actually clears history.
What's that?
Clear history, you find.
You can clear history, and I think that I would be interested to know what that really does. I bet it clears the internet history, but probably not the history index. So an interesting question. I've had people ask me in Internet Explorer, when you go up here and you click a bar and it offers you things, how do you clear just one entry out of there? And it's possible in Internet Explorer, but I'm not sure here. It's an interesting issue, and I don't know the simple answer. But the basic answer in all this forensics is that many, many records are being kept all over the place of everything you do. And if you aren't willing to just clean the whole drive, you're never going to be sure you got them all. Anyway, yeah?
What if you use a search engine like DuckDuckGo that is said to...
I think it still goes to the same place, but I don't really know. I don't think it's tied to... A search engine is a separate issue, so I shouldn't have said just Google. Google's the default, but if you set it to something else, then I think the records are still kept on your machine. The only thing about DuckDuckGo is it doesn't keep them at their company. So if you subpoena DuckDuckGo, usually they subpoena Google or something to get your search history. But if they subpoena DuckDuckGo, they supposedly don't have as much. But I don't think your browser knows that. I think it stays just as much locally. It's a good question. All right, so the cache has got source code of websites, images, other supporting files that were cached temporarily. And cookies, of course, has a record of anything you logged into, and also tracking cookies from ad networks everywhere you go, so it's pretty much got your whole browsing history also. All right, and then there's downloads, which is even more fun. There's a bunch of records Chrome keeps of your downloads, and this records the URL, how big the thing you downloaded was, when you downloaded it, and remember when you download something, Chrome says, wait, you can't use it yet, I'm checking to see if it's a virus. So it records Chrome's decision about whether it's malicious or not. So this is often awesome if you're doing a malware type investigation where you often find a record here of exactly when the malicious thing was downloaded, if Chrome flagged it. Anyway, Then there's Autofill. This again has your address and anything else you frequently type in. Chrome remembers it and it's all there and it's enabled by default. And you got Bookmarks. Stores everything in a JSON format with the date the bookmark was added in the URL. So everything is there. It's also got a backup file, which is handy in case somebody deletes the first one thinking they're saving themselves. And you got preferences, and this has all the installed plugins and extensions. And remember, when you install Chrome, the first thing it says is use Google Sync. Log into Chrome so your bookmarks and everything will be migrated to the other machine. This always irritates me. I use Chrome all the time, and every time I install it, it tells me turn on our cloud feature to save all your bookmarks in the cloud. I don't use it, but they're always trying to get me to use it, just like every Apple device is always trying to get me to use iCloud. And if they are, then that's even more awesome. That means that the data is copied to multiple devices and you can subpoena Google for it. So that's like Dropbox. That means there's copies of it everywhere and it's very difficult to believe that the perp will find a way to erase them all. All right, so here's fun things here, where files are going, the last directory, the download directory, and this is even more fun, the zoom settings for websites. Some websites you zoom in, other websites you zoom out. It remembers those and it stores them like shell tags. It stores them, and they persist even when history is cleared. There's a record of your zoom settings for websites. So that's what I mean. Things like incognito mode and clearing the history don't really remove all the traces. They remove the immediate thing that you could see right in front of you, and they weren't really intended for forensic cleaning, so they didn't really bother to hunt up all the secondary things created by your activities. So here's a record of where you've been going that's still there after you clear your history. And there's probably a lot more. Anyway, like I said, Chrome changes very quickly. There are very few specialized tools out there. There are some generic viewers that let you read SQLite and JSON files, and Nursoft has some Chrome-specific tools. They seem pretty vigorous about updating them. All right, so that's Chrome. Firefox is, I think, a very small player in the world, but as you'd imagine, it's pretty much like Chrome. It was early. Firefox was really the first browser back in the early days before Internet Explorer, really. The very early versions of Firefox came from Mosaic, I think. But anyway, so it stores these files in SQLite and JSON formats, just where you'd expect them to go: app, data, roaming, Mozilla, Firefox. Roaming and local refer to whether a profile in a domain environment should move as you log into different machines. But just like the low folders, it doesn't really matter that much to an investigator. It's an internal Windows issue where it stores them. All the objects in either folder mean that somebody did do that thing. And so in your profile data is stored in a file with a random name, a random 8-letter name.default, because you can actually have 8 different profiles in Mozilla for some unknown reason. You know, there was a time in the ancient past, like Windows 95 and Windows 98, there were people who had multiple people sharing one login and they still wanted to sort out their email or something. So Mozilla had the ability to have different profiles in the browser, even though you logged into the same account. And that's what this was for. But anyway, in here you got your cookies, your form history, your autocomplete features, your bookmarks, and your download history, and so on, all stored in these files. So the usual stuff is here: your history, list of downloads, bookmarks, autofill data, cookies, and cache. You have to have all that to do anywhere on the internet, and all those store essentially the same information, keeping a pretty thorough record of what you've been doing. Then you can adjust which artifacts will be saved. Here you can stop it from saving history, you can tell it to clear on exit, and you can tell it to clear, I think, the cache, limit the size of the cache, so it will clear more often. But these things have default settings and save quite a lot by default. And you can use SQLite Viewer to open any of those files, and you can go to Nursoft and download a bunch of files specific to Firefox. They seem quite dedicated to making a lot of browser files to get each one of these types of evidence out of each popular kind of browser. All right, I got a few eye clickers about that, and then we'll take a break, because there's more. All right, the most popular browser, something that changes every now and then.
And we mean current, right?
That's right, because it changes. Remember, I used to teach web design, and every class it seemed to change. For a while, there was a real race. I'll quit at 30. About 5 years ago, there was like 3 competitors, all about equal. But now Chrome won. All right. What's the standard browser in corporations? I guess I can quit at 25. All right, it's IE still because nobody jumps on the latest version. And perhaps someday it will be Edge, but it's going to be the Microsoft product almost certainly. All right. Which IE artifact is stored in the registry? Now I'll quit at 30. All right, and that's autocomplete. Go to popular answer. These are all stored as files, and that's not an IE artifact. That's for things like instant messengers. These are all files stored in various places, but autocomplete is in the registry, and I used to be up on how they kept changing the encryption in every version of IE, because it's a high-value target for hackers, and there were various attacks against it, and then they'd upgrade the encryption, and that would stop the attacks for a while. Because if you can suck out the stored passwords out of there, that's gold. Anyway, and there are various attacks that do that. All right, which Chrome artifact has search terms? Looks like I can quit at 30. All right, that's the history index. All right. And which Chrome artifact recognizes malware? Which is mighty convenient. Quit at 30. All right, and it's the downloads. The downloads logs do tell you if it detected this thing as being malicious. So let's take a break till 7:15, give you 10 minutes, and I'll stop this thing and call it